All right, welcome everyone for this week's Rising Tide Foundation lecture, where we are continuing the theme of Science Unshackled. This is a very important and interesting topic because there are many discoveries that either have been made or are waiting to be made that are not fully being appreciated by the majority of the those who suffer from certain standard model assumptions about the way the world works. So in the course of the last several months, really, we've been putting into questions just certain assumptions that are held to be true, which are blocking certain creative motion in the minds of scientists that are preventing us from realizing what is the structure and the nature and the flow of the direction of in this case we're going to look at earthquakes and the next necessary wave of discoveries that has to happen if humankind is going to properly move as we must into becoming a species that is endowed with the mandate to not only make discoveries into the fabric of physical space-time, but translate those discoveries into new technologies that give us better mastery over said universe that we were created into, and that thus allows us to have a better quality of life, leap beyond the limits to growth that are constantly pressing upon us. And I was very happy about a decade ago. I first encountered the thoughts and the work of Professor Pulinets when I listened to the proceedings of a conference hosted by the Schiller Institute in, I think it was 2011. And I read some of Dr. Pulinets's papers on a much healthier approach to earthquake forecasting, but also certain insights into the nature of the magnetic field, the ionosphere, and what human beings can do if we act with knowledge of the various properties of the Earth that not only can make life better by increasing the bounty of nature, but also understand how we could avoid the very foreseeable catastrophes that periodically smack into human civilization, as we saw very recently in the case of Syria and Turkey, that has resulted in over 50,000 deaths. There is going to be many more such instances, and if we're not prepared to think in a very different and healthy way, we are going to suffer very, very badly for that. So, Professor Pulinets, I mean, your biography is immense. Everyone has received it. I hope that people have had a chance to go to your website and to explore some of your work. In any case, today you will deliver a few remarks. I'm very appreciative of you giving your time, and after your formal remarks are finished, like usual, I ask people to put their names in the chat box, and I will call upon you in queue to pose a question or a thought to Professor Pulinets. So with that, it is all yours.
Good afternoon. First, I would like to say a few words. Who am I? I'm working in the Russian Academy of Sciences in the Space Research Institute. During my life, I worked in different, how to say, disciplines of the space science. Started from the studies of the ionosphere. We launched the satellites with the topside sounders. By the way, the first topside sounder was launched by Canada. It was Alouette 1 in 1962, I suppose. And during my presentation, I will show the results from the Alouette satellite, just as the ionospheric precursors registered by this satellite. We process the data later on, but nevertheless, we consider that topside sounding one of the most powerful instruments for studies of the ionosphere. So, more or less, like 30 years ago, when we discovered some anomalies just with the help of the topside sounder on Intercosmos 19 satellite, I started to be involved in these studies. And step by step, I realized that before we understand the physics of the generation of these anomalies, we would not be able to say something proceed to the earthquake forecast. So the last more or less 20 years, we were working on the creating of the physical model, and I will try to show you some results from this. Okay. So we will start from the classical approach to the seismogenesis, and we will discuss what are problems with this, and then we will discuss our model, and I will demonstrate some results of the short-term precursors, because the long-term earthquake prediction more or less works. But the main thing, when we need to do something just before the earthquake, no one country in the world has any practical applications for the short-term earthquake forecast. And we will discuss why, what are the problems, and how to overcome these difficulties and come to a conclusion. Do you see changes in the slides? Because sometimes, okay. So the classical approach tells us that we are living on the planet. The Earth's crust consists from different tectonic plates. Here you can see the structure of main tectonic plates. There are some borders inside the plates, but they are not shown here. But more or less, how it works. The plates are moving in different directions, and due to this, they interact between them, and we can see the different types of interactions which are shown here in the right picture. You can see that interaction creates the eruption of the Earth's crust, and this eruption can be in different directions. These are the normal faulting, when you see one part of the Earth's crust shifts down along the thrust, along the fault. The second one, it is reverse faulting, and goes up over the neighboring plate. And the last type of the moving, they strike slip faulting. The plates move along the fault. This is a case of the California, where the Cocos plate, Nazca plate, the Juan de Fuca plate, they are moving along the North American plate. And what is happening when interaction takes place? We have accumulation of the stress, and when it reaches its limit, we have the breaking, and this is a moment of the earthquake. If we have our crust without any irregularities, we may expect the regular appearing of the earthquake when they have the points of breaking, but unfortunately it happens in a irregular way by different reasons, and these reasons sometimes we understand, sometimes do not understand. And main problem that the physical nature of the earthquake and seismogenesis is not clear yet. Why? Because the pressure inside the crust, especially in the deep cases, is so strong that these parts of the earthquake crust, due to friction, cannot move. They need some lubrication, and they produce some models where we have some fluids or gas fluxes which permit to the parts of the crust move. But it is not proved. So up to now, in the seismology, the physical mechanism of earthquake is not clear up to now. Let's move. I'm sorry, I should not change the title of the slide, but I will explain. In the more or less 50 years ago, the situation of seismology was optimistic. People had a model of the dilatancy. It is a formation of the cracks and saturation by the water, and there were different types of dilatation, and there were field measurements of different parameters. Some what are parameters? It's electrical conductivity, the level of water in the wells, geomagnetic anomalies, gravitational anomalies, anomalies of the seismic waves propagation, especially the relationship between the longitudinal and transverse waves with changes before earthquakes, and many other types of anomalies which were called the precursors. And this is an example of the paper published in Science in what this is 1973, Earthquake Prediction, a Physical Basis. But if we look more carefully, this did not help to make the prediction. For the long history of the seismology, no one of the strongest earthquakes, something like Tohoku earthquake, Sumatra earthquake, L'Aquila earthquake, and many, many others, no one of them were predicted. Regardless, there were measurements, and in California, the park field, they have plenty of instruments deepen into the up to 1 kilometer of depth, different strain meters, and so on, but it does not help. Still, the problem is of prediction is not resolved. And there was some crisis of seismology in the end of the 90s, in 1997, and this are shown the so-called the earthquake temporal development between previous and next earthquake. This time is divided for several phases when the irregularity is shaping, and we have transfer from the elastic transformation to the non-elastic, and this is we came to the stage of the preparation of the earthquake when the short-term precursors are generated. And here I've shown several types of the precursors. One of them, it is radon, which will be very important in our model. And left part, it is an American model. Right part, it is a Russian model. They are more or less similar. Both of them have the radon emission as one of the precursors. So one more important thing which was discovered and established again in Russia by Dobrovolsky and co-authors. Their paper was published in 1979, and David Bowman with the co-authors, which was published in 1986, something like this. Both of them claim that there exists so-called the earthquake preparation zone. What does it mean? That there is a region on the Earth's surface where we can register the short-term precursors. And the size of this region depends on the magnitude. Here is the formula of Dobrovolsky. Radius in kilometers could be calculated if we know the magnitude of the earthquake. It is 10 in the 0.43 of magnitude, and to Bowman has and co-authors has 44, with this very small difference. And you can see that how strongly differs the size of the earthquake preparation areas depending on the magnitude. If for magnitude 5 we have the radius of 141 kilometers, for magnitude 7 we have the radius 1,000 kilometers. It means that if we calculate the area of this earthquake preparation zone, it will be more than 3 million of square kilometers. And you can see how it looks in our measurements. It is where it is in China. We see the earthquake preparation area. This is the epicenter, and it is a radius of it is not China, it is Kashmir earthquake, 2005, magnitude 7.6, for which the radius was 1,850 kilometers. And you can see how huge can be these areas which show anomalous behavior. For the strongest earthquake, it is Gujarat earthquake in January 2001. And the yellow color, it is a thermal anomalies. It is increase on the ground surface temperature registered a few days before the Gujarat earthquake. And you can see that it follows the shape of tectonic plates borders. And this circles, blue it is Dobrovolsky, and red it is Bowman, areas of the earthquake preparation. And this one, it is example of the earthquake preparation for the Aquila earthquake, which happened in Italy in 2009. Magnitude of the earthquake was 6.3. Again, you can see the thermal anomalies on the ground surface, and that they are inside the earthquake preparation area. And here are shown the appearance of the OLR emission. What is this? It is outgoing long-wave infrared radiation, which is measured by infrared spectrometers on both the satellite, NOAA satellites, European satellites now. And these are measurements of my colleague Dimitar Ozunov, and it shows how day by day appearing the anomalies are dancing inside the earthquake preparation area. It is for the Nepal earthquake 7.8 in 2015. Now we will start with the modeling, and I would like to say a few words about the academician Vernadsky, who started his life in the second half of the 19th century and passed away in 1945. And his idea are very extended. His studies started the many directions of the in different areas, but for us, the results are connected with the studies of radium, from which radon is generated, and he was founder of the Radium Institute in St. Petersburg, and he first used such phrase like the gaseous respiration of the Earth. What we are talking about? In these earlier works, all measurements were limited by the Earth's crust. So the people do not look at what happens in the atmosphere, regardless that the earthquake preparation, it is a very extended processes, including not only the Earth's crust. The Earth's crust not covered by the shield. It connects to the atmosphere, and most natural way of interaction of the Earth's crust with the atmosphere, it is gases. Gases which are emitted from the Earth's crust. Gases which we have prospecting and now use, and we have some conflicts connected with the gases. That is the methane. But there are the set of gases which are emitted from the Earth's crust. It is carbon dioxide, nitrogen, hydrogen, helium, and among these gases is radon, which differs from other gases because it is radioactive. And due to its radioactivity, it impacts on the Earth's atmosphere and changes its properties, which is very important in our model. And Vernadsky put the idea of the geospheres interaction, right? What means that all we live in the planets which consist of different geospheres. It is ocean, Earth's crust, atmosphere, ionosphere, magnetosphere, and he put forward idea of the noosphere, where the human knowledge also is concentrated and make place, make influence on the Earth, on the life of our planet. And his ideas are very important regarding the biosphere and interaction of the biosphere with other geospheres. So now we will talk about the radon. If we take the distribution of the radon in space, and especially if we will register its distribution on the ground surface, we will see that the maximum distance where the radon is registered before earthquakes follows the Dobrovolsky law. So this is a line which shows the dependence of the distribution of the different precursors, including the radon, depending on the magnitude. On the horizontal axis, you have magnitude of the earthquakes. Vertical, it is a radius of the earthquake preparation zone. And we have the very extensive review of the French seismologists Tutin and Babron, who reviewed many papers of the geochemical measurements, and they showed that radon follows the Dobrovolsky formula. And okay, we will not talk about this discussion in seismology. And if we look how radon acts in the atmosphere, he emits the alpha particles, which with higher energy, with energy 5.6 nega electron volts. And there are three main isotopes of radon. Actually, it is something like 20 isotopes of radon, but the three main isotopes of radon have their genetics coming from different elements. One of them, it is thorium, and if we will see the decay of the thorium, finally we will have isotope of radon, radon 220, and because this its father is thorium, it is called thoron. The second one, the semi-decay period is 53 seconds. So for 53 seconds, half of the emitted from the ground radon is decayed, and after this we will obtain the polonium. Second one, it is actinon, which comes from the decay of the actinium, and it is called actinon. And the main isotope which we are working with is coming from radium, directly from radium, and because of that, it is called radon. Its decay period is 3.8 days. So even one emission or one pulse of the radon emitted on the ground surface will act on the atmosphere during 3.8 days continuously. The very important thing that alpha particle is large, and it cannot propagate on the long distance in the Earth's atmosphere because of the collisions with atmospheric molecules of atmospheric gases. So its free path in the atmosphere is something like from 4 to 5 centimeters. Even if you put the sheet of the paper, it will not be able to pass through the sheet of the paper because it will be stopped by it. But during this pass, the shorter traces are formed, and alpha particles collide with the molecules of the gas and produce ionization. What means ionization? They collide with the particles and remove the electrons, and molecules of gases, atmospheric gases, convert into the ions. They start to be electrically charged, what is very important. And if we look at the ionization potential of the gases, these are different gases: argon, nitrogen, hydrogen, carbon dioxide, and other gases. It is from more or less 10 up to 16 electron volts. And energy of one alpha particle is 5.6 mega electron volts. So one alpha particle creates something like 3 power 10 in the 5th degree molecules, ionized molecules, so electron-ion pairs. let's go. And here is shown what happens as a result of the ionization. Here are shown the primary ions, which are formed after the colliding with alpha particles. But then they enter into some chemical reaction and creates a new charged molecules, which are different from the primary ions. And then starts very important process, which called the hydration of ions. What does it mean? We have water vapor in air, and molecules of the water vapor are polarized. And due to this, they started to be attached to the ions by different sides of this dipole of the water molecules. So by the positive two atoms of hydrogen, they attach to the negative ions, and by negative ion of oxygen, they are attached to the positive ions. And there are created very complex compounds, which are called the cluster ions, because they are growing, and large number of the water molecules started to be attached to the ions, and they form the large particles which grow to the size something like 1 to 3 microns. It is a very large size compared with aerosols. We have formation of the charged aerosols consistent from the complex ions created from the molecules of the air and attached water molecules. I'm sorry, it is a paper written in Russian, but I will explain you what is this. This reaction, if we look on the lower axis, are very fast. We obtain the final ions during 1 second. So after the emitting radon in the atmosphere, immediately are formed these cluster ions. And the reaction which creates these ions is autocatalytic. What does it mean? During this reaction is formed some compounds which called hydronium. And this hydronium works like catalyzer. He launched again and again this reaction, and we see the blow up process of forming of these large ions, like explosive reaction, which is characteristic to the critical processes which are described in the theory of synergy. And it is autocatalytic reactions are characteristic to many critical processes which are happening in different media, and here we talk about the atmosphere. And here are examples of the blow-up reactions which are observed in the nature and which are connected with the earthquake. Here is is shown how developed the radon emission before the Kobe earthquake in 1995. And it has I forgot how it will be in English. Okay, and this explosive development of the different parameters we can observe before the earthquake. This is a chemical potential. I will tell you what later what is this. before the Japanese earthquake with magnitude 7.3 in March 2022. So we are coming to the more late dates. And here you can see how develop the processes of the many precursors, but they concentrate around the same time before the two earthquakes in Nepal in 2015. It was the first earthquake with magnitude 7.8 on 25 April 2015, and second on the 12th of May with magnitude 7.3. You can see again this blow-up reaction, and it is followed by all types of the precursors which we are measuring. Here we see ionospheric tech, or VLF emissions, ground temperature growing atmospheric, outgoing long wave radiation, and radon. All of them, many precursors, follow the same behavior before the earthquake. So, sorry. And we, during our studies, we developed the parameter which called the atmospheric chemical potential. What is this? We consider the process of the ions hydration, and we use the such interesting feature that during attachment of the water molecule, or if we talk about the condensation, evaporation, if we have the pure water drop or surface of the water, during evaporation or condensation, we have the change of the energy of the water molecule. It is called the latent heat. So the energy of the free water molecules flying in the air is larger than the energy of the water which is inside the water drop. This difference in energy called the latent heat. And during this act of the attachment or condensation or evaporation, this latent heat is equal to the chemical potential of the water. And we discovered that during the attachment or hydration of the water molecules, this difference in energy larger than the during normal condensation evaporation. And the difference between these energies we called the correction of the chemical potential of the water vapor molecules in the air. And this correction of the chemical potential, to shorten this, we call this chemical potential or atmospheric chemical potential, ACP. Here you can see. And he works like the proxy of the radon. You probably know that measurements of the radon is very difficult, and it is difficult to provide this measurement everywhere where we have the earthquake activity. But if we use the atmospheric chemical potential, which can be calculated from the air relative humidity and temperature. What is this? this is the formula of the ACP. You see that here only the air temperature and humidity. But from this, we can calculate this correction of the chemical potential, which is, as yet it was established, that is proxy of the radon variations. Here you see the measurements of the radon in one of the Italian geophysical observatories. Blue line, it is a row of measurements. It is running median, the green line. And here is at the same point where the radon measurements are provided, we calculate the atmospheric chemical potential. You can see that it is behavior is very similar, and so it means that we can, using the simply meteorological data, we can calculate and see the radon activity in different areas. Sometimes people ask why you can interpret the correction of the chemical potential as a radon activity. This is a normal for the physical measurements, and let us look. If we measure your temperature of your body, are you measuring really the temperature? You measure the expanding of the mercury in the tube. The volume of mercury changes with the temperature. So you calibrate this expansion of the mercury in the degrees and say that is your temperature. But really, you use completely different physical process to measure your temperature. The same, for example, when we measure electric current. You have here magnet which interacts with the constant magnet, and dependent on the current, it will move around this constant magnet, and we put the arrow here, calibrate, and say that we measure the electric current. But actually, we use the magnetic field generated by this current and then calibrate it to the measurements. The same we are doing here. We use the effect which produce radon in air to measure, we try to calibrate it and say that we measure the activity radon of the air. And here we have examples of its behavior for different cases. Here you can see how it works. So before earthquake, we observe the increase of the air temperature and decrease of the air humidity. From this, we calculate the atmospheric chemical potential. Here is on this picture, you see the changes of the atmospheric parameter before the earthquake in Crete, magnitude 6 earthquake, 27 September 2021. The red line shows the moment of the earthquake. In the horizontal axis, you see September 2021 in days. And you can see that few days before the earthquake, we see the increase of atmospheric chemical potential, decrease of the relative humidity, increase of the air temperature, formation of the aerosols, and small decrease of the air pressure. The nature of decrease of air pressure is following. Generally, air pressure consists of the partial pressures of the different gases in the atmosphere, including the water vapor. And if you decrease the content of the water vapor, it decreases the partial pressure of the water vapor, which make influence in the total pressure. So we see the small decrease of the pressure during decrease of the relative humidity of the water vapor. So this is just shown the decrease of the air pressure before the earthquake in Japan. You can see it is Japan, it is Sakhalin Island in March 2022. And you can see the deep decrease of the air pressure over Japan, and this is the epicenter of the earthquake. And it happens 1, 2, 3, 4, 5 days before the earthquake. And we can, in case if we had the forecast of the weather forecast, the real weather forecast, they cannot predict something like the explosive changes in atmosphere, because they do not know that there is some source of these changes. So if we had a real forecast, the humidity was following this curve, something from this level, temperature will change in such way. But unfortunately, we do not have real forecast of weather because they are very tricky. They correct the forecast if this forecast not show the real behavior of the atmosphere. But if we sometimes have the real forecast, we can calculate the difference between the atmospheric parameter we have taken into account the earthquake preparation and weather forecast, and this is the difference between them, between the weather forecast and between our chemical potential and weather forecast in the Kuril Islands before the earthquake in April 2022. This was discovered many years ago, but it was published in the very rare local publication in Middle Asia. So I found this by the case. And what is this? It is earthquake in Chile in March 2023. So it is more or less 1 month ago. And I would like to show you here, you can see the blue curve. It is atmospheric chemical potential. Green curve, it is air humidity, and red curve, it is air temperature. Now we will look some animation. It is a Chile. It is a border it is of Chile. It is Pacific Ocean. It is epicenter in water. And it is a special distribution of the chemical potential, and we will see how it changes. Every picture, it is 3 hours between them. And we look in the epicenter. Here we see the precursor which lasts few hours. So 3 pictures that it is 9 hours. And I attract your attention again. Let's stop. Epicenter is in water. It is in open ocean. And if we look on the air humidity, I have the ASCII file here, but I can say use the number. It is 1% of the air humidity. You can imagine in the natural conditions, in open ocean, the air humidity 1%. It is impossible. So this is a proof that this anomaly was created by the air ionization. Only source of ionization is radon. It is more or less close to the shore, and radon is emitted also in the water as well. Sorry, I didn't change the text. I was in hurry preparing this presentation, but we have two main consequences of the ionization. First, it is a air anomalies. It is a nucleation induced by ion, the release of the latent heat, and due to release, which is in water molecules, due to release of latent heat, changes of the temperature and corresponding changes of humidity and pressure. And the second, also important consequence of the air ionization, it is that created the large charged clusters change the air conductivity, electric conductivity. And if we look on this picture, we will see this is an ionosphere and ground. We live in the global electric circuit due to thunderstorm activity and activity of the large convective clouds. The electric charge is provided to the ionosphere. It is charged positively in relation to the ground, and potential difference between the ionosphere and ground, it is more or less 250 kilometers. It can change in some periods of time up to 300, 200 kilovolts, but it is an order of magnitude 250 kilovolts in relation to the ground surface. And in the areas of the fair weather, in fair weather conditions in this global electric circuit, so this is generated by the thunderstorm activity, and in areas of the fair weather we have the return current. The return current is very small. You see 4 peak amperes per square meters. But the potential drop near the ground surface is something like 100 volts per meter. If you stand on the ground, the potential difference between your legs and head is more or less 200 volts. But you do not feel this because of higher conductivity of human body. It consists of the fluids, with the charged fluids, so we do not feel this. But in reality, the potential gradient near the ground surface is 100 volts per meter. But if you change, here is the boundary layer, so the lower layer of the atmosphere, if you change this conductivity, decreasing the conductivity, so you increase the resistivity, you increase the potential difference, you will have 200 volts up to several kilovolts per meter, which is observed before the earthquake. And these changes of the air conductivity and in general electric properties of air column is induced in the ionosphere the irregularities of the electron concentration, which we can observe with the satellite measurements or GPS tag measurements. Here is the GPS tag anomaly over the Aquila 1 day before the earthquake in Aquila. And here now we are coming to the multiple parameters measurements. We can see the changes of the air temperature, the latent heat flux, the ionospheric anomaly, outgoing long wave radiation, GPS tag, chemical potential, and surface temperature. This all was registered within the time interval from 3 to 1 days before the Aquila earthquake. So because of the large attention which was applied to this earthquake, we have many kinds of different parameters, and you see that many different parameters demonstrate the short-term anomalous behavior inside the atmosphere. So this was a foundation for our model. The schematic presentation of the model is shown in this left part of the figure. So activation of faults produce due to formation of some cracks, new cracks from this. This creates a new waves of the gas migration. And during this gas migration, namely by the carbon dioxide and methane, radon as a heavy gas is bringing by these gases to the surface and starts the formation of the ions due to ionization, formation of the aerosol-sized particles, which change the air conductivity, lead to the relative humidity drop. This is the drop of the humidity shown before the Islamabad, before the Pakistan earthquake in October 2005. Latent heat release, air temperature growth, OLR anomalies, outgoing long wave radiation. Convective ion uplifts, is a source of the formation so-called linear earthquake clouds, which we can observe by satellites. Air pressure drop is due to pressure drop. We observe the jet streams. For example, these jet streams are used by aviation to put the airplane on the jet streams, and sometimes you come to the destination earlier than it was planned because your airplane was inside this jet stream, which are in the altitude more or less of tropopause. So in the ionospheric part, we see atmospheric electric field growth, electric field penetration into the ionosphere, creation of the anomalies in the ionosphere, and trapping of the VLF noises in the plasma ducts formated by these ionospheric irregularities. And here you can see the schematic presentation of these models, this anomalous electric field penetration into the ionosphere and creating the different effects along the geomagnetic field lines. So it is a complex model, and something like this presentation can be given for any kind of these parameters. And this is a multi-parameter approach. We have several satellites which are measuring different parameters. We have ground-based measurements. We have remote measurements of electromagnetic emissions. All this can be used for the earthquake forecast. This is our monographs. You can see development of our model. The first monograph was published by Springer in 2003, 14, 18, 2 monographs, and the latest one was published on the Christmas of the last year. was Christmas gift for me. So some examples, it is a formation of the, you can see if we create the particles the size of 1 micron, we can start to see them like a fog. And you can see fog around the epicenter of the some earthquake in China. This is an example of the cloud formation before the Nepal earthquake. In general, the lifetime of the cloud is 1 hour, but this cloud was conserved during a few days, more or less 2 days. And you can see here the NEPs, the special distribution of the atmospheric chemical potential in different time. You can see still we see anomaly. This is a relative humidity, and this is a air temperature. And I attract your attention that these distributions are obtained on the altitude 100 meters of the over the ground surface. So the cloud, which is several kilometers, we have the prototype of protocloud near the ground surface, and this is transferred to the altitude of the formation of the cloud. A few words about ionospheric anomalies. There are 3 types of models, which is we talked the changes of the air conductivity, penetration of the electric field in the ionosphere, and in Japan and other countries, they use the model of the acoustic gravity waves, which are generated on the ground surface and create anomalies in the ionosphere. And I will show you our latest presentation, which was published a few weeks ago. And this is allocated for Canadian people. This is a Good Friday earthquake. It was an earthquake in Alaska with magnitude more than 9. It is one of the largest earthquakes in the history of our planet, with magnitude 9.2 of the 28th of March, 1964. And this is a map which was created. You can see the positive anomaly. This is the epicenter of the earthquake. This map was created based on the data of the Alouette, American-Canadian satellite in 1964. And we can show that this mechanism works always. You have 57 years difference, and this is a map calculated using the GPS tech. Again, this is Alaska to the south of Alaska, magnitude 8.2, and we can see the similar positive anomaly over or inside the earthquake preparation zone. This is the border of the earthquake preparation zone. You can see which was calculated using the Dobrovolsky formula in magnitude of 8.2. And these anomalies are penetrating in the ionosphere and create the anomalies in the conjugated, magnetically conjugated points, which are connected between them by the geomagnetic field lines. And these anomalies could be measured by VLF emissions, which are registered by the satellites. And this is all the data. It is a Cosmos 1809. It is also was our satellite, and we can see the anomalies in the conjugated points. And again, in the modern times, we see here the yellow squares. This is the VLF emissions registered by Chinese satellites, which is now in orbit, and they regularly register these conjugated anomalies by in ELF, VLF band of the electromagnetic emission. VLF, it is very low frequency. It means between 20 hertz up to 20 kilohertz electromagnetic emissions. And you can see them in this publication. And this is a calculation how these plasma ducts are formed. Okay, I suppose we should finish so we can move further. This is different types of the ionospheric anomalies. We see that we can distinguish them in the special maps where it is a days, it is a local time. We see nighttime positive anomaly, very similar like stalactites and stalagmites. And here again, the results of this ionospheric anomaly in 1998 named Hector minus quake 7.1, and 2018, 20 years later, we see the same types of the anomalies. These are the publications which were during these years. And here, this is a multi-sensor approach. So we have several satellite sensors from which we obtain information, and using like our lithosphere-atmosphere-ionosphere coupling model, data mining, integration of the data, detection of the anomalies, using the satellite and ground-based sensors of these different physical processes. We model, calculate, and finally obtain the forecast. Now we started to use the artificial intellect. Here is the schematic presentation, and we try to come to the automation of data processing, because we do not have many people, and we try to detect these pre-earthquake anomalies automatically. And we have some, this is another approach, and this is a schematic presentation of measurements in the Kamchatka, in Kuril Islands with a GPS tag. And here are some results of the ionospheric anomalies in low latitudes. We see equatorial anomaly before the earthquake in India, Myanmar border. This is a volcano anomalies before the volcano eruption in the Kamchatka, in Hawaiian Islands. So I probably will move to the end, because I see we have, I spent a lot of time explaining the model. This is some statistical results. This is a results of the Demeter satellite, which was in orbit from 2004 to 2010 during 6 years. And here on the horizontal axis are days where around the time of the earthquake. 0, it is a moment of the earthquake, and we see that mainly ionospheric anomalies are concentrated near the 5 days before the earthquake. It is a statistical data for more or less 6,000 earthquakes globally. The same we obtained in the ground-based measurements with ionozones. It is in Taiwan again 5 days. This is a statistical again from the Demeter, and here we have the days, and here is the distance from the epicenter, and here is the statistical tech measurements, and we can estimate the statistical validity of this data, the statistical confidence that they show that they are real precursors. This is for OLR, and I would like to say that, of course, I am not alone. We work in the close cooperation with the different scientists from United States, Japan, Russia, again, Japan, Taiwan, Italy, Japan, China, Russia, Italy, Greece. And here our meetings in the different conferences. This is the two most important Japanese scientists, Seiya Ueda, the academician of several world academies. He passed away a few weeks ago. It is Kanamori, one of the people who really studied the physical mechanisms of the earthquakes. So we are coming to conclusion that seismotectonic processes operate like an open, non-equilibrium, non-linear system with dissipation, in which all geospheres interact. It should be considered using the synergetic approach. The physical model, which I tried to explain for a long time now, shows a complete picture of the processes of generating. And to register, we should use the multi-sensor approach. But to use this multi-sensor approach, we need to have the special companies, projects, and so on. And it is not possible to individual people to make the global earthquake forecast. There are a lot of difficulties. Sometimes we have the false alarms. Sometimes we do not see precursors, and many other difficulties. But we had humanity had many problems. For example, problem of cancer. But for example, 50 years ago, cancer was the death sentence. But now we can cure the cancer, at least some types of the cancer. So if to work on the problem, we can solve. The problem is that actually in present times, seismologists do not work on the short-term forecast. They claim that short-term forecast is impossible. So in this area are working people like me and colleagues I demonstrated you in previous slide, but all of them are space physicists, electromagnetic, radiophysicists. Some seismologists cooperate with us, but it is very few to resolve the problem. And in general, this written by Red, despite the fact that the proposed technologies make it possible to make a short-term forecast, it will be possible only if a specialized public service is organized. The state should take part in this process, like firemen and so on. Otherwise, we will never be able to predict the earthquake, because by individual person it is impossible. It is very difficult to organize the global monitoring of all these anomalies in different regions of our globe. So here I will stop with part of optimistic claiming that it is possible, and pessimistic that until the states will take care of this, we will be not able to have a real-time earthquake forecast. Thank you very much.
Thank you very much, Professor Pulinets. And for those listening who found it difficult to believe your final remarks that there is resistance in the scientific community, I went to the United States Geological Survey website as you were speaking, and on the topic of earthquake forecasting, the official line, and it's hard to believe, especially after listening to a common sense basic presentation, which doesn't speculate into anything. You're using very, very provable evidence and facts that have been it's just so clear. And what they literally say on this topic of can we forecast earthquakes, their answer is no. Neither the United States Geological Survey nor any other scientists have ever predicted a major earthquake. We do not know how, and we do not expect to know how at any time in the foreseeable future. They've forecasted that the impossibility of ever discovering how this works when it has already been done over the decades. It's mind-boggling. I guess what would you say would be the biggest?
And they are in very comfortable situation, because when they want to get money, they speak about the protection, about the safety by which they provide with their science. But in reality, they say we are studies of physics, studies the behavior of the Earth's crust, but we do not predict.
Mm-hmm. Yeah. Oh, it's sad. Well, I was enlivened to see the array of collaborators that you have around the world, and I was curious. I'll ask this first question, and then I'm going to pass it over to John, and then Harinder and Luc. My question is, do you find that there are any parts of the world or any nations or parts of the world or institutions which are more open to this way of thinking in a multi-parameter fashion about forecasting, both in theory but also in terms of doing something in practice?
Okay, I will say your sad story. I had hope that private business will be interested in this. And more or less 2 years ago, I found the interesting company which is called Quantectum and has their headquarters in Slovenia. I connected with them. They invited me. We started to elaborate the technologies of the short-term forecast. And this is an example of our collect work. This, for example, they calculate the shear traction and behavior of the faults globally. And this is an example of their curve of the shear traction before the earthquake in Japan. Okay, that doesn't matter what is an earthquake. And here you can see that atmospheric chemical potential exactly coincides the maximum. For me, it's problem that, yes, for example, you asked me, did you see anomalies before the Turkey earthquake? Yes, I have seen, but I cannot, if I devote all my time to looking only on Turkey and collected the data every day, I was able to see this anomaly before the Turkey earthquake. But of course, I go to my work and I could go to rest. I can be sick and so on. I do not look continuously. I look at the data after the earthquake, and there was very strong anomaly 3 days before the Turkey earthquake. But again, it was discovered after the earthquake. This is for this Quantectum. This is you can see the faults. This is a earthquake, I suppose, in Crete, and there anomaly of shear attraction, and this is the anomaly of the chemical potential, and this works very nice. But then the owner of this company invited some well-known seismologist. His name is Izmiran, and he convinced that what we are doing is bullshit. He sold to him the company which is called RichterX, which uses ETAS technology, which is based on the calculating on the aftershock sequences. They predict very good the aftershock sequences, but okay, the main damage is produced by the ionosphere. But he convinced him, and they stopped contract with me, and now they are not working with the earthquake prediction. They work with companies of how to say, to sell the seismic risk to and not with the prediction.
Mm-hmm.
So again, the private sector wants to have the income, some income, but from the earthquake prediction, you will not have it. You you should organize to save the people, to evacuate them. So it should be governmental body. Private sector does not want, because it will have no aim. Income.
Yeah.
So the story of cooperation stopped. Now I don't have approach to this data. Again, we are in the same situation.
Yeah. John, do you have your question?
Sure. Большое спасибо за вашу беседу.
Oh,
thank you very much for your talk. I have one general question and one more specific question. Does the significant advance in earthquake prediction come from the availability of new data, given all the new satellites that have been put up, especially by Russia in the last 2-3 years? Or does it come from the discovery of previously unknown physical principles? Or is it a combination of the two?
Repeat, please, once more.
Okay. Does the significant advance in earthquake prediction come from the availability of significantly more new data? Or does it come from the discovery of previously unknown physical principles?
Okay,
or both, or a mix of both.
It depends of both, but the main difficulties we have is the false alarms. All the anomalies which I have shown, they really appear before earthquakes, but sometimes we observe them and earthquake does not happen. There are some unresolved questions between the precursors and triggers of the earthquakes. If you have some triggers, you don't need precursors. And there are some proofs that solar activity, the hurricanes, the large pressure gradients, and other physical phenomena in our environment, for example, the removed earthquakes can serve as a triggers. So in this situation, we are in doubtful situation, or we use the precursors or we follow the triggers. There are some scientists or researchers who more rely on the triggers. And there are other problems, for example, with chemical potential. We calculate it from air temperature and humidity. And for example, we are taking the situation around the Crete. But if we go south, we have very hot and dry air over Africa, where the chemical potential is much larger than we observe near the Crete. But it is not connected with the earthquake, but simply with the meteorological conditions in this area. So for every area, the chemical potential should be calibrated in taking into account the weather conditions in this or in one or another region. For example, in the region of the Central America, there is very high humidity, and in these conditions, its chemical potential is very small. We should develop the sophisticated procedures to find these precursors. The same in the Indian Ocean. So there are many difficulties, but it can be solved if more people will work on these more sophisticated techniques of the data processing will be developed. Unfortunately, with this technology, I work alone. One or two people which help me, but not in physics, but in preparation of the software for data processing.
My second question is more focused. So you focused on, if I understand correctly, proxies, on the detection of atmospheric anomalies.
Not only
as well
ionospheric
as well as electrical changes in the atmosphere, all the way up to the ionosphere, that seem to occur close to the epicenter of a future earthquake. And that leads me to but here we're focusing on things that are measurable in and around the Earth or close to the Earth. My question is, what are there external agents that might be involved in provoking or at least promoting these atmospheric electromagnetic changes, such as variations in the solar wind or variations in the electrical currents connecting the sun with the Earth, that might be involved in the production of the earthquakes?
Okay, let us separate the problems. The solar activity really creates also the anomalies in the ionosphere and in electrical properties, but we resolve this problem. We can distinguish between the anomalies created by the earthquake preparation process and solar activity. They have different features, and it is possible to distinguish between them. And the second part, you ask if the solar activity can provoke the seismic activity. I can say in general, yes, but it is still this question. We only started to work on this. There was few preliminary works, and now we will concentrate in these problems as well. For example, now it is a global project. It's called the Global Meridian, which involves many countries, and they will study the meridian something like 120 east and 60 west. So it is, and for the first time, there were included the problems, both the solar terrestrial relationships and seismic activity as a part of this interaction. And I suppose these problems will be studied during this project. Project is huge, and I hope that I will participate in a workshop in September this year in China.
That's very exciting.
Thank you very much.
What's the name of this project that you just mentioned?
Okay, we continue discussion. I will
Okay.
look in my.
All right, no rush about that. That's a technicality. And I suppose, just as a quick thought, the development of artificial intelligence, as you alluded to, could provide a really very useful solution to the problem of data management and processing, because people have to sleep and eat and live lives. Have you found that there's been a good progress on that front of utilizing the AI in order to determine or detect these anomalies in the mountains of data coming in so far, or is that still a ways to go?
Yes, we have some progress. As I told, we can distinguish between the geomagnetic and solar activity and earthquake activity. We can find automatically the precursors, but still we are fighting with the false alarms.
Okay.
And you maybe will have a question why I am using this atmospheric ionosphere. There it is possible to use the more data, more types of the physical measurements. But the problem is approach to this data. For the atmospheric anomalies, we use the NASA GEOS model, which is in internet. I can download the data of parameters of atmosphere and global scale. And for ionospheric, again, the GPS tag or tag data are also provided by IGS. So sitting in home, I can download the data for both parameters. For other parameters, okay, I cannot have the data for radon measurements in all stations in Italy or the other countries. It is very difficult. People do not want to share their data. And for example, for OLR, it is necessary to download the data from different satellites of remote sensing. It also time-consuming processing. So here I am doing what I can do by myself, sitting at home. By the way, it is very cheap. You do not need. Yes, if people say it is difficult, no, it is not difficult. It's necessary to organize in proper way.
Mm-hmm. Right. The next question is from Harinder.
Good afternoon, Professor Pulinets. I guess it is afternoon in Russia, or is it?
Yes, it is late afternoon.
Late afternoon.
Yes.
Okay, unlike you, my level of scientific literacy is very low, but I did get the impression that there are various, and from your various slides, it was clear that there are so many different things working together to create these the particles that you mentioned, the gases, which produce effects like atmospheric anomalies, ionizations, etc. And you have created a model, or you are proposing a model to be able to predict earthquakes. Do you think there is any possibility? We have heard that the United States, the Pentagon, has geoengineering technology that operates very high in possibly in the ionosphere. And it is widely believed that they are able to produce things like forest fires, floods, with the use of these technologies. Until now, that was just a theoretical construct. But now looking at, I hope I'm not going too fast for you, because I know you're translating into Russian, and or you may have difficulty with the English. So
yeah, no, I perfectly understand you.
Okay. So, for instance, if they have the technology to artificially create ionization or atmospheric anomalies through geoengineering, your model is talking about using this information to predict. And even there, you have pointed out that you don't always get the results because you are hoping for more cooperation, more data from other countries and so on, and you want states to get involved because the corporate sector for the time being does not see a motivation. Is it possible that these very processes that you have mentioned could be engineered for the purpose of actually creating or encouraging an earthquake? Because the allegation was made, although people said we don't have evidence yet that this massive earthquake in Turkey may have been geoengineered, but we don't know. But your presentation suggests that it could be possible, because if ionization is to be used as a prediction method, the manipulation of that ionization, if it were possible to a sophisticated power like the United States, could be used in the opposite way to actually generate an earthquake.
Okay. About engineering. From the point of view of the engineering of these effects, it was tested already. I was working for a few years in Mexico, and there was a company who created the special installations for the air ionization. And they used this installation for producing the artificial rains to fill the water reservoirs, to fight with the forest fires, to increase the precipitation in the desert areas of Mexico, and even to fight with the hurricanes. And they were very successful in this. So there is no doubt that it could be engineered, this processes of the air ionization, because it was done. But you should keep in mind this ionization, it is not the reason, but the consequence of the earthquake preparation. And with this, it is not possible to provocate the earthquake.
I see.
From the other side, I can say there are technologies which are working even now. It is magnetohydrodynamic sounding of the Earth, and these experiments were provided in Russia, and now such installation is in Kyrgyzstan. And what they are doing after this sounding, more or less 1 or 2 weeks after this sounding, there is initiated the series of the small earthquakes. So they try to initiate the small earthquakes to prevent this area from the strong earthquake, to release the energy by series of the small earthquakes. But from the physical point of view, the one magnitude of in Richter scale, the energy from, for example, magnitude 5 and magnitude 6 differs by 30 times. So to provide the energy comparative with the strongest quake, you need to initiate the thousands of the smaller quakes. So many scientists say that such sounding doesn't provide the protection from the strongest quakes. But nevertheless, the fact is that by these electromagnetic soundings, it is possible to initiate those quakes.
Thank you.
Luc, are you there? If you are, you're on mute. I can see your lips moving, but I cannot hear you.
Microphone. Switch on the microphone.
Can you hear me now?
Yeah.
Yes.
Perfect. Cool. Thank you. Thank you, Sergey, for obviously there's a lot of work having been done, and there's a lot of factors that you're looking at. I had a question on the technical side, but I also had a question on philosophically, or sometimes does the community hypothesize the why or the purpose that the earthquakes may contribute? It might be a funny questions, but we know that sometimes there's forest fires and that they serve a purpose of renewal for the forest. So I'm just wondering if what are your thoughts on that, or what is the common thinking in the community of people who study the earthquakes?
What do you mean that earthquakes can be used to renovate the state of our crust, or what do you mean?
Well, I'm trying to just see the problem from another perspective. Do we know that there's a contribution of new gases that are changing life on Earth afterwards, for example, so that there could be a purpose of seeding the atmosphere with new chemicals, for example? What do you think?
Okay, it is difficult to answer on your question. The initiation of the earthquake can show the more safe areas on our planet where people can move. We do not have problems with the earthquake. This is a reason, but it is very interesting that actually people know where the dangerous areas. But the problem is that strong earthquakes happen rarely in the specific point. Okay, we have strong earthquakes globally in many cases, but in specific point, for example, in Aquila, the strongest quake was more or less 100 years ago. So people forget about this. And they still you can see that they stay near volcanoes. They know that there was Vesuvio eruption. There were eruptions in many other volcanoes, but strong eruptions happen very rarely. People still build their houses close to the dangerous sources. So it is difficult. It is kind of human mentality who forgets what happened many years ago.
Yeah, it's a surprisingly interesting question. At first, when you were asking it, I was thinking, oh, are you implying that like earthquakes are beautiful or something? But no, it actually is a pretty interesting concept of the idea of the necessary natural cycles from within the Earth that relate to the emissions that participate in the growth of the biosphere and beyond. It's an interesting idea. But then how to then apply that to the question of then saving lives, which has to happen. That's obviously the next thing, which is as Professor Pulinets pointed out, it's a conceptual problem. Why do we make it a habit of living on top of high risk zones periodically, or not listening to good advice?
And regarding the new gases and so on, we know that our atmosphere was modified if we take the time scale of million or even billions of years. And so the biosphere changed according to changes of the atmosphere. So if something would happen with the gases and so on, so humanity will change to adapt to the new conditions of life.
Do we have evidence of earthquakes or other planetary quakes on other planetary bodies that is not the Earth that might give us some insight also into other variables shaping those quakes here in our part of the solar system? Or does that data not really exist?
Okay, the earthquakes happened in all planets of the solar system.
Oh, yeah. Okay.
It is known, yes. So we see the huges in the solar system, the volcano in Mars.
Right. Okay. Thank you. Nathan has been waiting for a bit, and I think this might be the last question for today.
Sure. Thank you for such an excellent lecture, because I've generated so many questions that I'm going to have to really dig into the whys. And but just as two things really. So obviously, a lot of the people in some of the cities, like Anchorage, where the 64 earthquake was, is on silt, and it's a big city. It's half the state lives in that city, and they're not going to move it. So obviously, the prediction of as long as more people are researching that and working to increase the predictive model of how longer and longer people can have time to get out of the city when the earthquake happens, because that seems to be the way to go. I mean, that whole city is on silt. Okay, it's gonna jiggle right into the ocean. But so the other question I have, is, well, that really wasn't a question, but it's more of an endorsement of your predictive approach. And it makes sense. You're saying that a lot of radon is in areas of high seismic activity in different geological areas. So has anybody studied the spin of the Earth as predict the fluctuations as maybe? I'm really struggling to understand the currents and model as it relates to the Earth's dielectric currents. And I was wondering, is there a relationship in the fluctuations in the spin of the Earth in terms of predictive abilities?
Okay, let's go step by step. Regarding evacuation, there was only one case in history in China when the earthquake was really predicted, and the people were really evacuated. This saved a lot of lives, because next year, almost in close area to this previous one, there was another strong earthquake, and it was not predicted, and 250,000 people were victims of this earthquake. So the patient has really may help. And for example, in Turkey, it was simply necessary to go out of the houses, not to be evacuated, but to go out, because you have seen they collapsed the houses like cards. So the prediction may help very strong. And for example, in Kobe case, there were a lot of fires because the gas pipes, electricity provoked the fires, and Kobe in those times was constructed from the wood, and there was a lot of damage in the city. But if they had prediction, they could switch off the electricity, the gas, and the damage would be much less. And the second, remind me what your question was about.
Okay, so just general fluctuations in the spin of the Earth.
Spin of the Earth.
Mm-hmm.
Okay, there are some scientists who claim, and there are some statistical data showing that acceleration or deceleration of the Earth's rotation, and it happens continuously, may serve as a trigger for the earthquakes. Because like in bus, when you have just stopped all the people, so the same effect happens during the sharp changes of the velocity of the Earth's rotation.
I suppose for my last, I'll throw in one last question that relates to the idea of methodology. And what you've just presented in the past 2 hours is a very, very refreshing way of just thinking in general in a very intersectional manner. I mean, you've brought up matters of chemistry, radiation, electromagnetism, atmospheric science. I mean, there's so many different venues that you're synthesizing in your mind to look upon as from a top-down perspective. And it is very liberating to take this exercise on. And I was just curious, looking through your biography, I was happily surprised to see that you are also a musician and a poet. And I was curious if you find that an experience with classical music in theory and practice and arts, did you find that this classical culture enriched your ability as a scientist to think in these terms, or do you think that these are sort of two different worlds, that it's just a coincidence?
Oh, I think that music and not only music, other types of art opened the mind. So you still remain an open-minded person. This helps. and you can relax from scientific work.
Yeah, what you're saying sort of, it reminded me a little bit of a quote from Einstein that I remembered from many years ago when he was describing how when he would become blocked on a mathematical problem that he was trying to solve, he would take a break and go to his violin and return back to the problem and find all sorts of solution concepts arising that he could not have expected otherwise. So it's yeah, it's interesting. Well, Professor Pulinets, I think you've given us quite the tour of a very healthy, organic approach to science, earth science, and so much more. So I thank you so much for taking this time generously to introduce us to this world that you've been living in and helping to expand as well, and recruiting, I think, and inspiring other people to take on the mission of thinking about the future in this much more healthy way. So thank you once more, and all of the links to your books I'm going to make available in the description box of this video. So for people listening on YouTube, they can go and buy your books, read them, go to your website, other things to immerse themselves in greater detail. So thank you so much, and thank you everyone.
Yes, and I want to thank the audience. Sorry, sometimes my speech was chaotic, but it is due to lack of time. I had not to prepare more carefully, but I suppose you get impression what is happened now in this field. Thank you very much.
Many thanks for your talk.
Thank you, sir.
Thank you.
Thank you.
Спасибо, Professor.